Plane geometry. Plane geometry is about flat shapes like lines, circles, and triangles, shapes that can be drawn on a piece of paper. 2D shapes. Regular polygons. A polygon is a plane or 2D shape with straight sides. Other common polygons. These are 2D shapes and they are polygons, but not regular polygons like quadrilateral, any four-sided 2D shape, rectangle has four sides, all right angles, and many more. Curved shapes. These are also 2D shapes but are not polygons because they have curves, like circle, ellipse, and many more. Polygons. Is it a polygon? Polygons are two-dimensional shapes. They are made of straight lines, and the shape is closed. All the lines connect up, like polygon, straight sides. Not a polygon has a curve. Not a polygon, open, not closed. Polygon comes from Greek. Poly means many, and gon means angle. Types of polygons. Regular or irregular. A regular polygon has all angles equal and all sides equal. Otherwise, it is irregular. Concave or convex. A convex polygon has no angles pointing inwards. More precisely, no internal angle can be more than 180 degrees. If any internal angle is greater than 180 degrees, then the polygon is concave. Think, concave has a cave in it. Simple or complex. A simple polygon has only one boundary, and it doesn't cross over itself. A complex polygon intersects itself. Many rules about polygons don't work when it is complex. More examples: irregular hexagon, concave octagon, complex polygon, a star polygon, in this case, a pentagram. Names of polygons. If it is a regular polygon, triangle or trigon has three sides, interior angle is 60 degrees, quadrilateral or tetragon has four sides, interior angle is 90 degrees, pentagon has five sides, interior angle is 108 degrees, hexagon has six sides, interior angle is 120 degrees, heptagon or septagon has seven sides, interior angle is 128.571 degrees. Octagon has eight sides, interior angle is 135 degrees. Nonagon or enneagon has nine sides, interior angle is 140 degrees. Decagon has 10 sides, interior angle is 144 degrees. Hendecagon or undecagon has 11 sides, interior angle is 147.273 degrees. Dodecagon has 12 sides, interior angle is 150 degrees. Triskaidekagon has 13 sides, interior angle is 152.308 degrees. Tetrakaidekagon has 14 sides, interior angle is 154.286 degrees. Pentadecagon has 15 sides, interior angle is 156 degrees. Hexakidecagon has 16 sides, interior angle is 157.5 degrees. Heptadecagon has 17 sides, interior angle is 158.824 degrees. Octakidecagon has 18 sides, interior angle is 160 degrees. Enneadecagon has 19 sides, interior angle is 161.53 degrees. Icosagon has 20 sides, interior angle is 162 degrees. Triacontagon has 30 sides, interior angle is 168 degrees. Tetracontagon has 40 sides, interior angle is 171 degrees. Pentacontagon has 50 sides, interior angle is 172.8 degrees. Hexacontagon has 60 sides. Interior angle is 174 degrees. Heptacontagon has 70 sides. Interior angle is 174.857 degrees. Octacontagon has 80 sides. Interior angle is 175.5 degrees. Enneacontagon has 90 sides. Interior angle is 176 degrees. Hectagon has 100 sides. Interior angle is 176.4 degrees. Octacontagon has 80 sides. Interior angle is 175.5 degrees. Enneacontagon has 90 sides. Interior angle is 176 degrees. Hectagon has 100 sides. Interior angle is 176.4 degrees. Chiliagon has 1,000 sides. Interior angle is 179.64 degrees. Myriagon has 10,000 sides. Interior angle is 179.964 degrees. Megagon has 1,000,000 sides. Interior angle is 180 degrees. Googlegon has 10 raised to 100 sides. Interior angle is 180 degrees. Ngon has n sides. N minus 2 times 180 degrees divided by n. You can make names using this method. 20 sides. Start with icosi, end with henagon. 30 sides. Start with triaconta, end with digon. 40 sides. Start with tetraconta, end with trigon. 50 sides. Start with pentaconta, end with tetragon. 60 sides. Start with hexaconta, end with pentagon. 70 sides. Start with heptaconta, end with hexagon. 80 sides. Start with octaconta, end with heptagon. 90 sides. Start with enneaconta, end with octagon. 100 sides. Start with hecta, end with enneagon. Example, a 62-sided polygon is a hexacontadigon. But, for polygons with 13 or more sides, it is okay and easier to write 13 gon, 14 gon, to 100 gon, etc. Common 3D shapes: sphere, torus, cylinder, cone, cube, cuboid, triangular pyramid, square pyramid, triangular prism. Activity: sorting shapes. Let's sort flat shapes in different ways. You will need some shapes. You can buy some or make your own like this. Print out shapes in any color and then cut them out. Or print shapes in black and white on different colors of paper or card, cut them out, then mix them up. Or you might like to color them in yourself. Now we have our shapes. Let's sort them by color. That was easy. Now, for a harder task, sort them by size. This was how many shapes ended up. Your result may be different. Now, sort them by how many edges they have. I am not going to show you how, but here are some hints. A circle has one edge, a triangle has 3 edges, and there is at least one shape with 8 edges. Now, sort them by how many corners they have. Did anything change? What about the teardrop shape? Next, can you sort them by curves? Shapes with a curve, shapes with only straight edges. The ones with only straight edges are called polygons. And your last task, sort them by 2 methods at the same time, by color, but with the curved shapes on the top row. Here, I am sorting them by color and curve or not. Bonus task, sort them by color and how many edges. Now, just go ahead and combine the shapes into artwork. Triangles. A triangle has 3 sides and 3 angles. The three angles always add to 180 degrees. 3D shapes: equilateral, isosceles, and scalene. There are three special names given to triangles that tell how many sides or angles are equal. There can be 3, 2, or no equal sides or angles. Equilateral triangle: 3 equal sides, 3 equal angles, always 60 degrees. Isosceles triangle: 2 equal sides, 2 equal angles. Scalene triangle: no equal sides, no equal angles. How to remember? Alphabetically, they go 3, 2, none. Equilateral means equal, lateral means side, so they have all equal sides. Isosceles means equal legs, and we have two legs, right? Also, isosceles has two equal sides joined by an odd side. Scalene means uneven or odd, so no equal sides. What type of angle? Triangles can also have names that tell you what type of angle is inside. Acute triangle: all angles are less than 90 degrees. Right triangle: has a right angle, 90 degrees. Obtuse triangle: has an angle more than 90 degrees. Combining the names. Sometimes a triangle will have two names. For example, right isosceles triangle has a right angle of 90 degrees and also two equal angles. Can you guess what the equal angles are? Angles. The three interior angles always add to 180 degrees. Perimeter. The perimeter is the distance around the edge of the triangle. Just add up the three sides. Area. The area is half of the base times height. B is the distance along the base. H is the height measured at right angles to the base. Area is equals to 1.5 times B times H. The formula works for all triangles. Note: a simpler way of writing the formula is BH divided by 2. Example: what is the area of this triangle? Note: 12 is the height, not the length of the left-hand side. Height is equals to H is equals to 12. Base is equals to B is equals to 20. Area is equals to 1.5 times B times H is equals to 1/2 times 20 times 12 is equals to 120. The base can be any side. Just be sure the height is measured at right angles to the base. Why is the area half of BH? Imagine you double the triangle. Flip it around one of the upper edges to make a square-like shape, a parallelogram, which can be changed to a simple rectangle. Then, the whole area is BH, which is for both triangles, so just 1 is 1/2 times BH. Right-angled triangles. A right-angled triangle, also called a right triangle, is a triangle with a right angle of 90 degrees in it. The little square in the corner tells us it is a right-angled triangle. I also put 90 degrees, but you don't need to. The right-angled triangle is one of the most useful shapes in all of mathematics. It is used in the Pythagoras theorem and sine, cosine, and tangent, for example. Two types. There are two types of right-angled triangle. First, isosceles right-angled triangle. One right angle, two other equal angles always of 45 degrees, two equal sides. Second, scalene right-angled triangle. One right angle, two other unequal angles, no equal side. Example: the 3, 4, 5 triangle. The 3, 4, 5 triangle has a right angle in it. Draw one if you ever need a right angle. It has no equal sides, so it is a scalene right-angled triangle. Triangles contain 180 degrees. In a triangle, the three interior angles always add to 180 degrees. A plus B plus C is equals to 180 degrees. Example, find the missing angle C. Start with A plus B plus C is equals to 180 degrees. Fill in what we know. 38 degrees plus 85 degrees plus C is equals to 180 degrees. Rearrange. C is equals to 180 degrees minus 38 degrees minus 85 degrees. Calculate. C is equals to 57 degrees. Proof. This is a proof that the angles in a triangle equal 180 degrees. Notice that angles A are the same, angles B are the same. The top line that touches the top of the triangle is running parallel to the base of the triangle. And you can see that A plus C plus B rotates from one side of the straight line to the other, or a full 180 degrees. Pythagoras theorem. Pythagoras theorem. Over 2000 years ago, there was an amazing discovery about triangles. When a triangle has a right angle or 90 degrees, and squares are made on each of the three sides, then the biggest square has the exact same area as the other two squares put together. It is also called Pythagoras theorem and can be written in one short equation. A raised to 2 plus B raised to 2 is equals to C raised to 2. Note, C is the longest side of the triangle. A and B are the other two sides. Definition. The longest side of the triangle is called the hypotenuse. So, the formal definition is, in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Example, a 3, 4, 5 triangle has a right angle in it. Let's check if the areas are the same. 3 raised to 2 plus 4 raised to 2 is equals to 5 raised to 2. Calculating this becomes 9 plus 16 is equals to 25. It works like magic. Why is this useful? If we know the lengths of two sides of a right-angled triangle, we can find the length of the third side. But remember, it only works on right-angled triangles. How do I use it? Write it down as an equation. A raised to 2 plus B raised to 2 is equals to C raised to 2. It works the other way around too. When the three sides of a triangle make A raised to 2 plus B raised to 2 is equals to C raised to 2, then the triangle is right-angled. Then we use algebra to find any missing value, as in these examples. Solve this triangle. Start with A raised to 2 plus B raised to 2 is equals to C raised to 2. Put in what we know. 5 raised to 2 plus 12 raised to 2 is equals to C raised to 2. Calculate squares. 25 plus 144 is equals to C raised to 2. 25 plus 144 is equals to 169. 169 is equals to C raised to 2. Swap sides. C raised to 2 is equals to 169. Square root of both sides. C is equals to square root of 169. Calculate. C is equals to 13. Example, solve this triangle. Start with A raised to 2 plus B raised to 2 is equals to C raised to 2. Put in what we know. 9 raised to 2 plus B raised to 2 is equals to 15 raised to 2. Calculate squares. 81 plus B raised to 2 is equals to 225. Take 81 from both sides. 81 minus 81 plus B raised to 2 is equals to 225 minus 81. Calculate B raised to 2 is equals to 144. Square root of both sides. B is equals to square root of 144. Calculate. B is equals to 12. It works the other way around too. When the three sides of a triangle make a raised to 2 plus b raised to 2 is equals to c raised to 2, then the triangle is right-angled. Example, does this triangle have a right angle? Thus, a raised to 2 plus b raised to 2 is equals to c raised to 2. A raised to 2 plus b raised to 2 is equals to 10 raised to 2 plus 24 raised to 2 is equals to 100 plus 576 is equals to 676. C raised to 2 is equals to 26 raised to 2 is equals to 676. They are equal. So, yes, it does have a right angle. Example, does an 8, 15, 16 triangle have a right angle? Thus, 8 raised to 2 plus 15 raised to 2 is equals to 16 raised to 2. 8 raised to 2 plus 15 raised to 2 is equals to 64 plus 225 is equals to 289. But 16 raised to 2 is equals to 256. So, no, it does not have a right angle. We also have a proof by adding up the areas. Historical note: while we call it Pythagoras theorem, it was also known by Indian, Greek, Chinese, and Babylonian mathematicians well before he lived. Pythagorean Triples. Pythagorean triple is a set of positive integers a, b, and c that fits the rule a raised to 2 plus b raised to 2 is equals to c raised to 2. Example, the smallest Pythagorean triple is 3, 4, and 5. Let's check it. 3 raised to 2 plus 4 raised to 2 is equals to 5 raised to 2. Calculating this becomes 9 plus 16 is equals to 25. Yes, it is a Pythagorean triple. When a triangle's sides are Pythagorean triple, it is a right-angled triangle. Example, the Pythagorean triple of 3, 4, and 5 makes a right-angled triangle. Here are two more Pythagorean triples. 5 raised to 2 plus 12 raised to 2 is equals to 13 raised to 2. 25 plus 144 is equals to 169. 9 raised to 2 plus 40 raised to 2 is equals to 41 raised to 2. Try it yourself. And each triangle has a right angle. List of the first few. Here is a list of the first few Pythagorean triples, not including scaled-up versions mentioned below. 3, 4, 5, 9, 40, 41, 15, 112, 113, 20, 21, 29, 24, 143, 145, 28, 195, 197, 33, 56, 65, 36, 323, 325, 5, 12, 13, 11, 60, 61, 16, 63, 65, 29, 99, 101, 25, 312, 313, 29, 420, 421, 33, 544, 545, 37, 684, 685, 7, 24, 25, 11, 35, 37, 17, 144, 145, 21, 220, 221, 27, 364, 365, 31, 480, 481, 35, 612, 613, 8, 15, 17, 13, 84, 85, 19, 180, 181, 23, 264, 265, 28, 45, 53, 32, 255, 257, 36, 77, 85, infinitely many more. Scale them up. The simplest way to create further Pythagorean triples is to scale up a set of triples. Example, scale 3, 4, 5 by 2 gives 6, 8, 10, which also fits the formula a raised to 2 plus b raised to 2 is equals to 7 raised to 2. 6 raised to 2 plus 8 raised to 2 is equals to 8 raised to 2. 36 plus 64 is equals to 100. Quadrilaterals. Quadrilateral just means four sides. Quad means four. Lateral means side. A quadrilateral has four sides. It is two-dimensional, a flat shape, closed, the lines join up, and has straight sides. Properties. A quadrilateral has four sides or edges, four vertices or corners, interior angles that add to 360 degrees. Types of quadrilaterals. There are special types of quadrilateral. Rectangle, all angles 90 degrees, opposite sides equal. Square, all angles 90 degrees, all sides equal. Rhombus, all sides equal, opposite sides parallel. Parallelogram, opposite sides parallel and equal. Trapezoid, US. Trapezium, QK, two sides parallel. Kite, adjacent pairs of sides equal. Some types are also included in the definition of other types. For example, a square, rhombus, and rectangle are also parallelograms. Let us look at each type in turn. The rectangle. A rectangle is a four-sided shape where every angle is a right angle or 90 degrees. Also, opposite sides are parallel of equal length. The little squares in each corner mean right angle. The square. A square has equal sides, marked S, and every angle is a right angle or 90 degrees. Also, opposite sides are parallel. A square also fits the definition of a rectangle. All angles are 90 degrees, and a rhombus, all sides are equal length. The little squares in each corner mean right angle. The rhombus. A rhombus is a four-sided shape where all sides have equal length, marked S. Also, opposite sides are parallel and opposite angles are equal. Another interesting thing is that the diagonals or dashed lines meet in the middle at a right angle. In other words, they bisect or cut in half each other at right angles. A rhombus is sometimes called a rhomb or a diamond. The parallelogram. A parallelogram has opposite sides parallel and equal in length. Also, opposite angles are equal. Angles A are the same and angles B are the same. Note, squares, rectangles, and rhombuses are all parallelograms. Example, a parallelogram with all sides equal and angles A and B as right angles is a square. The trapezoid, UK trapezium. A trapezoid, called a trapezium in the UK, has a pair of opposite sides parallel, and the trapezium, called a trapezoid in the UK, is a quadrilateral with no parallel sides. An isosceles trapezoid, as shown above, has left and right angles of equal length and join to the base at equal angles. The kite. It has two pairs of sides. Each pair is made of two equal length sides that join up. Also, the angles where the two pairs meet are equal. The diagonals, shown as dashed line above, meet at a right angle. One of the diagonals bisects or cuts equally in half the other. And that's it for the special quadrilaterals. Irregular quadrilaterals. The only regular, all sides equal and all angles equal, quadrilateral is a square. So all other quadrilaterals are irregular. The family tree chart. Quadrilateral definitions are inclusive. Example, a square is also a rectangle. So we include a square in the definition of a rectangle. We don't say having all 90 degrees angles makes it a rectangle except when all sides are equal, then it is a square. This may seem odd, as in daily life we think of a square as not being a rectangle, but in mathematics it is. Using the chart below, we can answer such questions as, is a square a type of rectangle? Yes. Is a rectangle a type of kite? No. Complex quadrilaterals. Oh yes, when two sides cross over, we call it as a complex or self-intersecting quadrilateral, like this. They still have four sides, but two sides cross over. Polygon. A quadrilateral is a polygon. In fact, it is a four-sided polygon, just like a triangle is a three-sided polygon. A pentagon is a five-sided polygon, and so on. Other names. A quadrilateral can sometimes be called a quadrangle, four angles, so it sounds like triangle. A tetragon, four polygon, so it sounds pentagon, hexagon, and etc. Right angles. A right angle is an internal angle which is equal to 90 degrees. This is a right angle. See that special symbol like a box in the corner? That says it is a right angle. The 90 degrees is rarely written in. If we see the box in the corner, we are being told it is a right angle. All the angles below are right angles. A right angle can be in any orientation or rotation as long as the internal angle is 90 degrees. Never argue with a 90-degree angle, it is always right. Types of angles: acute, right, obtuse, straight, reflex, full rotation. Parallel lines and pairs of angles. Parallel lines. Lines are parallel if they are always the same distance apart, called equidistant, and will never meet. Just remember, always the same distance apart and never touching. The red line is parallel to the blue line in each of these examples. Parallel lines also point in the same direction. Parallel lines have so much in common, it's a shame they will never meet. Pairs of angles. When parallel lines get crossed by another line, which is called a transversal, you can see that many angles are the same, as in this example. These angles can be made into pairs of angles which have special names. Testing for parallel lines. Some of those special pairs of angles can be used to test if lines really are parallel. If any pair of, example, corresponding angles are equal, A is equals to E, or alternate interior angles are equal, C is equals to F, or alternate exterior angles are equal, B is equals to G, consecutive interior angles or add up to 180 degrees, D plus F is equals to 180 degrees, then the lines are parallel. Examples. These lines are parallel because a pair of corresponding angles are equal. These lines are not parallel because a pair of consecutive interior angles do not add up to 180 degrees. These lines are parallel because a pair of alternate interior angles are equal. Parallelogram in any quadrilateral. Inside any quadrilateral, a four-sided flat shape, there is a parallelogram, opposite sides parallel and equal in length. When we connect the midpoints, the point exactly halfway along a line, of each side of the quadrilateral, one after the another, we create a new shape that has opposite sides parallel, even though the containing quadrilateral might not. Midpoint of a line segment. Coordinate point. We can use Cartesian coordinates to locate a point by how far along and how far up it is. Here, the point 12, 5 is 12 units along and 5 units up. And when we know both ends of a line segment, we can find the midpoint M. Midpoint of a line segment. The midpoint is halfway between the two endpoints. Its x value is halfway between the two x values. Its y value is a halfway between the two y values. To calculate it, add both x coordinates, divide by 2. Add both y coordinates, divide by 2. As a formula, m is equals to xa plus ab divided by 2, ya plus yb divided by 2. 2 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 ya plus yb Example, what is the midpoint here? Use the formula m is equals to xa plus ab over 2, ya plus yb over 2. M is equals to negative 3 plus 8 over 2, 5 plus negative 1 over 2. M is equals to 5 over 2 and 4 over 2. M is equals to 2.5 and 2. Rectangle. A rectangle is a four-sided flat shape where every angle is a right angle or 90 degrees. The little squares in each corner mean right angle. Each internal angle is 90 degrees. Opposite sides are parallel and of equal length, so it is a parallelogram. Area of a rectangle. Area is equals to A times B. Example, a rectangle is 6m wide and 3m high. What is its area? Area is equals to 6m times 3m is equals to 18m squared. Perimeter of a rectangle. The perimeter is the distance around the edges. The perimeter is 2 times a plus b. Perimeter is equals to 2 times a plus b. Example, a rectangle is 12 cm long and 5 cm tall. What is its perimeter? Perimeter is equals to 2 times 12 cm plus 5 cm is equals to 2 times 17 cm is equals to 34 cm. Diagonals of a rectangle. A rectangle has two diagonals. They are equal in length and intersects in the middle. A diagonal's length is the square root of a squared plus b squared. Diagonal D is equals to square root of a squared plus b squared. Example, a rectangle is 12 cm wide and 5 cm tall. What is the length of a diagonal? D is equals to square root of 12 squared plus 5 squared is equals to square root of 144 plus 25 is equals to square root of 169 is equals to 13 cm. Golden rectangle. There is also a special rectangle called the golden rectangle. Rhombus. A rhombus is a flat shape with four equal straight sides. A rhombus looks like a diamond. All sides have equal length. Opposite sides are parallel, and opposite angles are equal. It is a parallelogram. The altitude is the right angle distance between opposite sides, and the diagonals P and Q of a rhombus bisect each other at right angles. Area of a rhombus. The area can be calculated by the altitude times the side length. Area is equals to altitude times S. The side length squared or S squared times the sine of angle A or angle B. Area is equals to S squared sine A. Area is equals to sine squared 2 sine B. By multiplying the lengths of the diagonals and then dividing by 2, area is equals to P times Q divided by 2. Example, a rhombus has diagonals of 6m and 8m. What is its area? Area is equals to 6m times 8m divided by 2 is equals to 24m squared. Perimeter of a rhombus. The perimeter is the distance around the edges. The perimeter is 4 times S, the side length because all sides are equal in length. Perimeter is equals to 4S. Example, a rhombus has a side length of 12 cm. What is its perimeter? Perimeter is equals to 4 times 12 cm is equals to 48 cm. Is a square a rhombus? Yes, because a square is just a rhombus where the angles are all right angles. Other names. It is more common to call this shape a rhombus, but some people call it a rhomb or even a diamond. The plural is rhombi or rhombuses, and rarely rhombi or rhombuses with a double B. The name rhombus comes from the Greek word rhombos, a piece of wood whirled on a string to make a roaring noise. Square geometry. A square is a flat shape with four equal sides and every angle is a right angle or 90 degrees. All sides are equal in length. Each internal angle is 90 degrees. Opposite sides are parallel, so it is a parallelogram. A square also fits the definition of a rectangle all angles are 90 degrees, a rhombus, all sides are equal length, a parallelogram, opposite sides parallel and equal in length, and a regular polygon, all angles equal and all sides equal. Area of a square. The area is the side length squared. Area is equals to A squared is equals to A times A. Example, a square has a side length of 6m. What is its area? Area is equals to 6m times 6m is equals to 36m squared. The area is also half of the diagonal squared. Area is equals to d squared over 2. Perimeter of a square. The perimeter is the distance around the edge. The perimeter is 4 times the side length. Perimeter is equals to 4a. Example, a square has a side length of 12 cm. What is its perimeter? Perimeter is equals to 4 times 12 cm is equals to 48 cm. Diagonals of a square. A square has two diagonals. They are equal in length and intersect in the middle. The diagonal is the side length times the square root of 2. Diagonal D is equals to 8 times square root of 2. Example, a square has a side length of 5m. What is the length of a diagonal? Diagonal length, 8 times square root of 2 is equals to 5 times 1.4142, 1, so on, is equals to 7.01 m to 3 decimals. Parallelogram. A parallelogram is a flat shape with opposite sides parallel and equal in length. Opposite sides are parallel. Opposite sides are equal in length. Opposite angles are equal. Angles A are the same and angles B are the same. Angle A and angle B add up to 180 degrees, so they are supplementary angles. Note: squares, rectangles, and rhombuses are all parallelograms. Example: a parallelogram where all angles are right angles is a rectangle. Area of a parallelogram. The area is the base times the height. Area is equals to B times H. H is at right angles to B. Example, a parallelogram has a base of 6m and is 3m high. What is its area? Area is equals to 6m times 3m is equals to 18m squared. Perimeter of a parallelogram. The perimeter is the distance around the edges. The perimeter is 2 times the base plus side length. Perimeter is equals to 2 times b plus s. Example, a parallelogram has a base of 12 cm and a side length of 6 cm. What is its perimeter? Perimeter is equals to 2 times 12 cm plus 6 cm is equals to 2 times 18 cm is equals to 36 cm. Diagonals of a parallelogram. The diagonals of a parallelogram bisect each other. In other words, the diagonals intersect each other the halfway point. Inside any quadrilateral. And there is a parallelogram in any quadrilateral. Trapezoid. A trapezoid is a four-sided flat shape with straight sides that has a pair of opposite sides parallel, marked with arrows below. A trapezoid has a pair of parallel sides, is an isosceles trapezoid when it has equal angles from a parallel side, is called the trapezium in the UK. The parallel sides are the bases. The other two sides are the legs. The distance at right angles from one base to another is called the altitude. Area of a trapezoid. The area is the average of the two base lengths times the altitude. Area is equals to A plus B2 times H. Example, a trapezoid's two bases are 6m and 4m, and it is 3m high. What is its area? Area is equals to 6m plus 4m over 2 times 3m is equals to 5m times 3m is equals to 15m squared. The area of polygon by drawing tool is helpful when you can draw your trapezoid. Perimeter of a trapezoid. The perimeter is the distance around the edges. The perimeter is the sum of all side lengths. Perimeter is equals to A plus B plus C plus D. Example, a trapezoid has side lengths of 5 cm. 12 cm, 4 cm, and 15 cm. What is its perimeter? Perimeter is equals to 5 cm plus 12 cm plus 4 cm plus 15 cm is equals to 36 cm. Median of a trapezoid. The median, also called the midline or mid-segment, is a line segment halfway between two bases. The median's length is the average of the two base lengths. M is equals to A plus B over 2. You can calculate the area when you know the median. It is just the median times the height. Area is equals to MH. Trapezium. A trapezium, UK trapezoid, is a quadrilateral with no parallel sides. The US and UK have their definitions swapped over like this. Trapezoid, US, a pair of parallel sides. UK, no parallel sides. Trapezium, US, no parallel sides. UK, a pair of parallel sides. Kite. A kite is a flat shape with straight sides. It has two pairs of equal length adjacent next to each other's sides. Two pairs of sides. Each pair is two equal length sides that are adjacent. They meet. The angles are equal where the two pairs meet. Diagonals or dashed lines across at right angles, and one of the diagonals bisects or cuts equally in half the other. Area of a kite. Method 1. Multiply the lengths of the diagonals and then divide by 2 to find the area. Area is equals to P times Q2. Example, a kite has diagonals of 3 cm and 5 cm. What is its area? Area is equals to 3 cm times 5 cm over 2 is equals to 7.5 centimeters squared. Method 2. Multiply the lengths of two unequal sides by the sine of the angle between them. Area is equals to A times B times sine or C. Example, you don't want to get wet measuring the diagonals of a kite-shaped swimming pool. So you measure an equal side, lengths of 5m and 6.5m with an angle between them of 60 degrees. What is its area? Area is equals to A times B times X or sine C is equals to 5 times 6.5 times sine or 60 degrees times 5 times 6.5 times 0.866 is equals to 28.1 m squared to decimal point. Method 3. If you can draw your kite, try the area of polygon by drawing tool. Perimeter of a kite. The perimeter is the distance around the edges. The perimeter is 2 times side length A plus side length B. Perimeter is equals to 2 times A plus B. Example, a kite has side lengths of 12m and 10m. What is its perimeter? Perimeter is equals to 2 times 12m plus 10m is equals to 2 times 22m is equals to 44m. Rhombus and square. When all sides have equal length, the kite will also be a rhombus. When the angles are also 90 degrees, the kite will be a square. A square is a kite? Yes, so it doesn't always look like the kite you fly. Dart. A concave kite is called a dart. Paper sizes. Did you know that international paper sizes like A3, A4, and etc. are based on the square root of 2? Because the square root of 2 has this cool property. 1 times square root of 2 times square root of 2 is equals to 2, which lets us have this. So, we can have sheets that exactly the same proportions, their ratio of side lengths are the same, and also fit in each other perfectly. Two A4s make an A3 and have the same proportions. These make things really efficient. Don't have any A3? Tape two A4s together. Don't have any A5? Cut an A4 in half. And because they have the same proportions, any artwork or document can be resized to fit on any sheet. Another benefit is that you can print something out of 70% size and fit two pages side by side on just one sheet like this. Why 70%? Because 1 over square root of 2 is equals to 0.7071, which is close to 70%. A similar enlargement is square root of 2 is equals to 1.4142, which is close to 140%. Sizes. The popular A4 size is 210 mm wide by 297 mm high. With a width of 210, the height is 210 times square root of 2 is equals to 297. Here are all the sizes cut from an A0 sheet, which has an area of 1 m squared. Lastly, here are the official sizes. A0, 841 times 1189, tabletop, 1 m squared. A1, 594 times 841, 0.5 m squared. A2, 420 times 594, monitor, 0.25 m squared. A3, 297 times 420, 0.125 m squared. A4, 210 times 297, writing sheet, 0.0624 m squared. A5, 148 times 210, 0.0311 m squared. A6, 105 times 148, 0.0155 m squared. A7, 74 times 105, note, 0.00777 m squared. A8, 52 times 74, 0.003848 m squared. A9, 37 times 52, 0.001924 m squared. A10, 26 times 37, stamp, 0.000962 m squared. Note, you can think of the A number as how many folds or cuts in half away from an A0 we are. So an A3 needs 3 folds of an A0, and so is 1 half times 1 half times 1 half is equals to 1/8 the size. Proportions. Proportion says that two ratios or fractions are equal. Example, 1/3 is equals to 2/6. So, 1 out of 3 is equal to 2 out of 6. The ratios are the same, so they are in proportion. Example, rope. A rope's length and weight are in proportion. When 20 m of rope weighs 1 kg, then 40 m of that rope weighs 2 kg. 200 m of that rope weighs 10 kg. So, 20 over 1 is equals to 40 over 2. Sizes. When shapes are in proportion, their relative sizes are the same. Here, we see that the ratios of head length to body length are the same in both drawings. So they are proportional. Making the head too long or short would look bad. Example, international paper sizes like A3, A4, A5, etc. all have the same proportions. So any artwork or document can be resized to fit of any sheets. Very neat. A concrete example. Ratios can have more than two numbers. For example, concrete is made by mixing cement, sand, stones, and water. A typical mix of cement, sand, and stones is written as a ratio such as 1:2:6. We can multiply all values by the same amount and still have the same ratio. 10:20:60 is the same as 1:2:6. So when we use 10 buckets of cement, we should use 20 of sand and 60 of stones. Squares and square roots. How to square a number. To square a number, multiply it by itself. Example, what is 3 squared? 3 squared is equals to 3 times 3 is equals to 9. Squared is often written as a little 2 like this. This says 4 squared equals 16. The little 2 says the number appears twice in multiplying. Squares from 0 squared to 6 squared. 0 squared is equals to 0 squared times 0 times 0 is equals to 0. 1 squared is equals to 1 squared is equals to 1 times 1 is equals to 1. 2 squared is equals to 2 squared is equals to 2 times 2 is equals to 4. 3 squared is equals to 3 squared is equals to 3 times 3 is equals to 9. 4 squared is equals to 4 squared is equals to 4 times 4 is equals to 16. 5 squared is equals to 5 squared is equals to 5 times 5 is equals to 25. 6 squared is equals to 6 squared is equals to 6 times 6 is equals to 36. Negative numbers. We can also square negative numbers. Example, what happens when we square negative 5? Answer, negative 5 times negative 5 is equals to 25 because a negative times a negative gives a positive. That was interesting. When we square a negative number, we get a positive result. Square roots. A square root goes the other way. 3 squared is 9, so a square root of 9 is 3. A square root of a number is a value that can be multiplied by itself to give the original number. A square root of 9 is 3 because when 3 is multiplied by itself, we get 9. Here are some squares and square roots. 4, 16, 5, 25, 6, 36, 7, 49. Decimal numbers. It also works for decimal numbers. Negatives. We discovered earlier that we can square negative numbers. Example, negative 3 squared. Negative 3 times negative 3 is equals to 9. And of course, 3 times 3 is equals to 9 also. So the square root of 9 could be positive or negative 3. Example, what are the square roots of 25? Negative 5 times negative 5 is equals to 25. 5 times 5 is equals to 25. So, the square roots of 25 are negative 5 and 5. The square root symbol. This is the special symbol that means square root. It is sort of like a tick, and actually started hundreds of years ago as a dot with a flick upwards. It is called the radical and always makes mathematics look important. We use it like this, and we say square root of 9 equals 3. Example, what is square root of 25? 25 is equals to 5 times 5. In other words, when we multiply 5 by itself, 5 times 5, we get 25. So the answer is square root of 25 is equal to 5. But wait a minute. Can't the square root also be negative 5? Because negative 5 times negative 5 is equals to 25 too. Well, the square root of 25 could be negative 5 or positive 5. But when we use the radical symbol, we only give the positive or 0 result. Perfect squares. The perfect squares, also called square numbers, are the squares of the integers. 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, 5, 25, 6, 36, 7, 49, 8, 64, 9, 81, 10, 100, 11, 121, 12, 144, 13, 169, 14, 196, 15, 225, and etc. Try to remember them up to 12. The easiest way to calculate a square root. Use your calculator's square root button. And also, you use your common sense to make sure you have the right answer. Square root day. The 4th of April 2016 is a square root day because the date looks like 4416. The next after that is the 5th of May 2025, 55525. Perimeter. Perimeter is the distance around a two-dimensional shape. Example, the perimeter of this rectangle is 7 plus 3 plus 7 plus 3 is equals to 20. Another example is the perimeter of this regular pentagon is 3 plus 3 plus 3 plus 3 plus 3 is equals to 5 times 3 is equals to 15. The perimeter of a circle is called the circumference. Circumference is equals to 2 pi times radius. Perimeter formulas. Triangle, perimeter is equals to A plus B plus C. Square, perimeter is equals to 4 times A. A is equals to length of side. Rectangle, perimeter is equals to 2 times A plus B. Quadrilateral, perimeter is equals to A plus B plus C plus D. Circle, circumference is equals to 2 pi r. R equals to radius. Sector, perimeter is equals to R sigma plus 2. R is equals to radius. Angle in radians. Ellipse, perimeter is equals to very hard. Area is the size of a surface. Example, these shapes all have the same area of 9. It helps to imagine how much paint would cover the shape. What is area? Area of simple shapes. There are special formulas for certain shapes. Example, what is the area of this rectangle? The formula is area is equals to W times H. W is equals to width. H is equals to height. The width is 5 and the height is 3. So we know W is equals to 5 and H is equals to 3. Area is equals to 5 times 3 is equals to 5. Area by counting squares. We can also put the shape on a grid and count the number of squares. The rectangle has an area of 15. Example, when each square is 1 meter on a side, then the area is 15 meters squared. Square meter versus meter square. The basic unit of area in the metric system is the square meter, which is a square that has 1 meter on each side. Be careful to say square meters, not meters squared. There are also square square cm, etc. Learn more at metric area. Approximate area by counting squares. Sometimes the squares don't match the shape exactly, but we can get an approximate answer. One way is more than half a square counts as 1, less than half a square counts as 0, like this. This pentagon has an area of approximately 17. Or we can count one square when the areas seem to add up. Example, here the area marked 4 seems equal to about one whole square, also for 8. This circle has an area of approximately 14. Area by adding up triangles. We can also break up a shape into triangles. Then measure the base and the height of each triangle. Then calculate each area using area is equals to 1/2 b times h and add them all up. Area by coordinates. When we know the coordinates of each corner point, we can use the area of irregular polygons method. There is an area of a polygon by drawing tool that can help too. Triangle. Area is equals to 1/2 times b times h. B is equals to base, h is equals to vertical height. Rectangle. Area is equals to W times h. W is equals to width, h is equals to height. Trapezoid US, trapezium UK. Area is equals to 1/2 times A plus B times h. H is equals to vertical height. Ellipse, area is equals to pi AB. Square, area is equals to A squared, A is equals to length of side. Parallelogram, area is equals to B times H, B is equals to base, H is equals to vertical height. Circle, area is equals to pi times R squared, R is equals to radius. Sector, area is equals to 1/2 times R squared times sigma. R is equals to radius is equals to angle in radians. Example, what is the area of this rectangle? The formula is area is equals to W times H. W is equals to width, H is equals to height. We know W is equals to 5 and H is equals to 3. So, area is equals to 5 times 3 is equals to 15. Example, what is the area of this circle? Radius is equals to r is equals to 3. Area is equals to pi times r squared is equals to pi times 3 squared is equals to pi times 3 is equals to 3.14159 times 9 is equals to 28.27 to 2 decimal places. Area of polygon by drawing. What is regular, concave, complex? When all angles are equal and all sides are equal, it is regular. Otherwise, it is irregular. When any internal angle is greater than 180 degrees, it points inwards, it is concave. Think, concave has a cave in it. Otherwise, it is convex. When the boundary crosses over, so the polygon intersects itself, it is complex. Otherwise, it is simple, like most polygons we deal with. Many rules about polygons don't work when they are complex. Activity, garden area. I don't have a garden, so what can I do? If you don't have a garden, maybe a friend has one or your relatives have one, so use theirs. How accurate should my measurements be? Try to measure to the nearest centimeter or half inch so the error will be as small as possible. You should get a good estimate as long as you are careful with your measuring. Is there a simple way to find the area of my garden? If your garden is a rectangle, then you have a simple calculation. You just have to measure its width and length and multiply them together. Rectangle, area is equals to W times L. W is equals to width, L is equals to length. But that makes this activity just too easy. So go find another garden with a more interesting shape. My garden is a difficult shape. So how can I find its area? Good, this activity just got interesting. It may be one of the shapes on the page area of plane shapes. Then you just have to decide which shape, make the measurements and use the formula. But you could also break up your difficult shape into triangles. Then measure the base and height of each triangle. Write down each measurement carefully so you know which triangle it belongs to. Now, go inside and calculate each area, using area is equals to 1/2 b times h and add them all up. But my garden is different. In fact, it's not any shape at all. It has some straight edges and some curved parts. What should I do? Maybe it looks something like this. You should try covering your garden with a grid of squares. These could be 1 meter squares or 1 foot squares, something like this. How do I make a grid? Try using pegs in the ground and join them up with string. Make sure they are the right distance apart and all angles are right angles. How does this help? The grid and the outline of the garden don't match. There are lots of corners and curved parts. Count the squares. There are special methods talked about on the area page. The simplest method is more than half a square counts as 1, less than half a square counts as 0. If your grid is 1 foot by 1 foot, then the area will be in square feet. An estimate for this area is 41 meters square. This is just an example. Your garden is different, of course. Why should I want to know the area of my garden? There might be lots of reasons. You want to returf the garden? How much grass should you order? How much will it cost? You want to plant the garden with tomato plants. These have to be planted a certain distance apart. How many plants could you plant? What will be your expected yield of tomatoes? You want to hold a barbecue party. How many people could comfortably fit into your garden? I am finished. What have I learned? You have learned something about measuring, recording data, drawing, and calculating area. Well done! Congruent. If one shape can become another using turns, flips, and/or slides, then the shapes are congruent. After any of those transformations, turn, flip, or slide, the shape still has the same size, area, angles, and light length. Examples. Here are 3 examples of shapes that are congruent. Congruent, rotated and moved. Congruent, reflected and moved. congruent, reflected, rotated, and moved. Congruent or similar. The two shapes need to be the same size to be congruent. When we need to resize one shape to make it at the same as the other, the shapes are similar. When we only rotate, reflect, and or translate, then the shapes are congruent. When we also need to resize, then the shapes are similar. Congruent. Why such a funny word that basically means equal? Maybe because they are only equal when placed on top of each other. Anyway, it comes from Latin congruere, to agree, so the shapes agree. Similar. Two shapes are similar when one can become the other after a resize, flip, slide, or turn. Resizing. If one shape can become another using resizing, also called dilation, contraction, compression, enlargement, or even expansion, then the shapes are similar. If there is no need to resize, then the shapes are better called congruent. There may be turns, flips, or slides too. Sometimes, it can be hard to see if two shapes are similar, because you may also need to turn, flip, or slide a shape. Examples. Here are the three examples of shapes that are similar: resized, resized and reflected, resized and rotated. Why is it useful? When two shapes are similar, then corresponding angles are equal, and the lines are in proportion. This can make life a lot easier when solving geometry puzzles, as in this example. Example. What is the missing length here? Notice that the red triangle has the same angles as the blue triangles. They both have right angle and a shared angle in the left corner. In fact, we can flip the red triangle over, rotate it a little, resize it, and it will fit exactly on the top of the blue triangle, so they are similar triangles. So the line lengths are in proportion. The blue triangle has two sides with a ratio of 130 over 127. The red triangle has matching sides in the ratio blank over 80. And we can calculate blank is equals to 80 times 130 over 127 is equals to 81.9. No fancy calculations, just common sense. Congruent or similar. Shapes are congruent when they are the same size but may have been rotated, reflected, or moved. So when the shapes become the same, when we only rotate, reflect, and or translate, then the shapes are congruent. Also, need to resize, similar. Are congruent shapes also similar? Most people, including us, say congruent shapes are also similar. Example, we can move and rotate the orange shape to exactly match the blue shape, so the two shapes are congruent. We don't have to resize for the shapes to be similar, so they are also similar even though no resizing was needed. Congruent angles. Congruent angles have the same angle in degrees or radians, that is all. These angles are congruent. They don't have to point in the same direction. They don't have to be on similar sized lines. Just the same angle. Congruent, why such a funny word that basically means equal? Probably because they are only equal when laid on top of each other. Anyway, it comes from Latin congruere, to agree, so the angles agree. How to find if triangles are congruent? Two triangles are congruent if they have exactly the same three sides and exactly the same three angles. But we don't have to know all three sides and all three angles. Usually, 3 out of 6 is enough. There are 5 ways to find it if two triangles are congruent: SSS, SAS, ASA, AAS, and HL. 1. SSS, side, side, side. SSS stands for side, 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 and means that we have two triangles with all three sides equal. For example, 547 is congruent to 457. If three sides of one triangle are equal to three sides of another triangle, the triangles are congruent. 2. SAS, side, angle, side. SAS stands for side, angle, side, and means that we have two triangles where we know two sides and the included angle are equal. For example, 3.6 49 degrees 7.1 is congruent to 3.6 49 degrees 7.1. If two sides and the included angle of one triangle are equal to the corresponding sides and angle of another triangle, the triangles are congruent. 3. ASA, angle, side, angle. ASA stands for angle, side, angle, and means that we have two triangles where we know two angles and the included side are equal. For example, 23 degrees, 124 degrees, 8.9 is congruent to 124 degrees, 8.9, 23 degrees. If two angles and the included side of one triangle are equal to the corresponding angles and side of another triangle, the triangles are congruent. AAS or AAS, angle, angle, side. AAS stands for angle, angle, side, and means that we have two triangles where we know two angles and the non-included side are equal. For example, 15, 42 degree, 76 degree is congruent to 76 degree, 42 degree, and 15. If two angles and the non-included side of one triangle are equal to the corresponding angles and side of another triangle, the triangles are congruent. HL or hypotenuse leg. This one applies only to right-angled triangles. HL stands for hypotenuse leg. The longest side of a right-angled triangle is called the hypotenuse. The other sides are called legs. It means we have two right-angled triangles with the same length of hypotenuse and the same length for one of the other two legs. It doesn't matter which leg since the triangles could be rotated. For example, 5.2, 7.9 is congruent to 7.9, 5.2. If the hypotenuse and one leg of one right-angled triangle are equal to the corresponding hypotenuse and leg of another right-angled triangle, the two triangles are congruent. Caution! Don't use AAA. AAA means we are given all three angles of a triangle but no sides. This is not enough information to decide if two triangles are congruent because the triangles have the same angles but be different sizes. 40 degrees, 110 degrees, 30 degrees is not congruent to 40 degrees, 110 degrees, and 30 degrees. Without knowing at least one side, we can't be sure if two triangles are congruent. Transformations. These are transformations: rotation, turn, reflection, flip, translation, slide. After any of those transformations, turn, flip, or slide, the shape still has the same size, area, angles, and line lengths. Resizing. The other important transformation is resizing, also called dilation, contraction, compression, enlargement, or even expansion. The shape becomes bigger or smaller. Congruent or similar. When one shape can become another using only turns, flips, and slides, when the two shapes are congruent. Two shapes are similar when we need to resize. For one shape to become another, we may also turn, flip, and/or slide. So, when one shape can become another using transformation, the two shapes might be congruent or just similar. When one shape becomes another using only rotate, reflect, and/or translate, the shapes are congruent. When one shape becomes another, using a resize, may also rotate, reflect, and/or translate, the shapes are similar. Rotation. Rotation means turning around the center. The distance from the center to any point of the shape stays the same. Every point makes a circle around the center. Reflection. Reflections are everywhere. In mirrors, glass, and here in a lake. Every point is the same distance from the central line, and the reflection has the same size as the original image. The central line is called the mirror line. Can a mirror line be vertical? Yes. Here my dog, Flame, shows a vertical mirror line with a bit of photo magic. In fact, mirror lines can be in any direction. Imagine turning the top image in different directions. A reflection is a flip over a line. Translation. In geometry, translation simply means moving, without rotating, resizing, or anything else, just moving. To translate a shape, every point of the shape must move, the same distance in the same direction. Writing it down. Sometimes we just want to write down the translation without showing it on a graph. Example, to say the shape gets moved 30 units in the x direction and 40 units in the y direction, we can write xy is equals to x plus 30 and y plus 40, which says all the x and y coordinates become x plus 30 and y plus 40. Resizing. When you resize a shape, it gets bigger or smaller, but it looks similar. All angles stay the same. Relative sizes are the same. For example, the face and body are still in proportion. Note, here we call it resizing, but other people call it dilation, contraction, compression, enlargement, or even expansion. Same idea, just different names. To resize, just do this for every corner. Draw a line from the central point to the corner. Increase or decrease the length of that line. Put a dot at the new point. Then, just connect the dots for the resized shape. Symmetry. Syn means together, plus metron means measure. Reflection symmetry. The simplest symmetry is reflection symmetry, sometimes called line symmetry or mirror symmetry. It is easy to see because one half is the reflection of the other half. Here, my dog Flame has her face made perfectly symmetrical with a bit of photo magic. The white line down the center is the line of symmetry. The reflection in this lake also has symmetry, but in this case, the line of symmetry runs left to right. It is not perfect symmetry as the image is changed a little by the lake surface. The line of symmetry can be in any direction, not just up, down, or left, right. To learn more, go to reflection symmetry. Rotational symmetry. With rotational symmetry, the image is rotated around the central point so that it appears two or more times. How many times it appears is called the order. Here are some examples. Point symmetry. Point symmetry is when every part has a matching part, the same distance from the central point, but in the opposite direction. It is also the same as rotational symmetry of order 2 above.